Okay, so we're on day 2 of 1.1. This slide is not on your notes. I just want you to look at it. We had the ruler postulate that said every point had a number value on a number line, yes? And we didn't write that down because we know that, right? I'm not writing this down. It is the protractor postulate. Well, this is a protractor. You know that. You've seen one before. It measures angles. Okay? So when you measure an angle, so you know, you put right here. Oh, it says creating new something. Okay, right here. See that? Not a lasso. Okay, right here. Why is it doing that? What?
I just said it says something on the board. Yeah. There you go.
Okay. So right here, I don't know why it's doing that. Right there, you put this crosshair. Most of them have a crosshair right here, and you put it, and you measure it. So when I look at A, B, C, what is the measure of A, B, C? So A, B, C. What's this angle measure right here? Where does it cross? 60 degrees. Now, under 60 degrees is 120. Is this angle 120 degrees?
No.
No, that angle isn't. The other one is. The angle right here is 120 degrees, isn't it?
Yes.
Okay? So when it's acute, it's going to be the smaller number. When it's obtuse, it's going to be what? The larger number. Xander, the assignment and everything's on the calendar, okay? And I am going to post this video up. So now let's go to actually using it, like, well, this is just going to measure. Okay, so I'm going to measure. And it wants to know BEC. So B, E, and C. Okay? Now, where is B cross the protractor at? It's not exactly anywhere, is it? So what do you guys think? Where do you think?
47.
47? Does that sound good? Okay. So we have 47 is this right here where B's crossing, right? And where does C cross?
105.
105. So if C crosses at 105 and B crosses at 47 and I want just in between here, how can I find that? Subtract. I can take 105 minus 47. And let's see, 8. I get 58. How about you guys? Okay, so I get 58. Okay, so what about AEC? Do I have to do any subtracting for AEC? And I don't even know what's going on right there.
No.
I don't know what a lasso is. Okay, I don't. So what is the measure of AEC?
105.
105. What about BED? So BED. Well, that one doesn't, so I need to know where B crosses and where D crosses. Where does B cross again?
47.
47. And where does D cross?
130.
130. If you can't read these pictures, please let me know. I will try to adjust them. I can only make them so big if I'm going to write on them too. So then I have to subtract them, yes?
Yes.
So then I get 10 is 3 and 12 is 8. So I get what?
83.
83. Pretty basic, right? Had to be reminded. Okay, so the next one. This is a postulate. You should have angle additional postulate on your paper, correct? on your notes? Does everyone have their notes out?
Yeah.
Did we forget we were supposed to be writing? Okay. So,
We're supposed to write those?
yes,
Where?
Oh.
right where, like, right on your notes where the picture is. No, on your note. Not these notes. Where's your notes I gave you yesterday?
Oh. Wait. I know that.
In here.
Oh yeah.
It's the beginning of the year.
Sorry.
Okay, so just skip to where we're at. You can go this. You got to watch the video to see if you can do it anyway, right?
Yeah.
So you can fill in the blanks from there. So,
I did this one on my website.
oh, well, that's interesting.
It's amazing.
Well, hopefully you can peel it off and reglue it.
Yeah.
That's what I had
Okay.
to do because I feel like upside down.
That's what she did. Okay, so now did everyone find the angle addition postulates on your notes I gave you yesterday? When I say notes, those were review notes. Okay, so you have if, and you have a picture. Oops, sorry. You have if and a picture, correct? Okay, so on that picture you have angles CBA, CBD, DBA, correct? You got lots of angles. So when we have that picture on the then, so next to it, where that blank space is, that I need to make a big old line next time, right? You're going to write M, well, what M means is measure. Got it? M means measure. Okay, so the measure of angle ABD, so that's here. ABD is right here. Yes? Okay. Plus the measure of angle DBC, which is right there. Yes? Equals the measure of angle ABC. So, well, if I cut a string and made segments and put it together and added it all up and equaled the whole thing, wouldn't that make sense to do it with angles? Yes. This was problem number 8 on your homework. Essentially. So, can I solve this problem by addition or subtraction, depending on what I'm missing? Yes. Okay, do you guys have your rule written down? Okay, so let's do an example. So now I have SPR. So SPR right here is 60 degrees. And guys, on your homework, make a picture so you can write in it. It will help. It will. And then SPQ, well, SPQ, that's the whole thing, isn't it? So the whole thing equals what? 119. So what does that mean that in here equals? How are we going to find it? Subtract it. So you're going to 119 minus 60. And I think you get 59 degrees, correct?
Yeah.
So
Yes.
angle QPR, measure of angle QPR equals 59 degrees. Oops. Okay. So now we got another problem. And I am going to tell you, you are going to have an application problem, at least one, about every day. And I expect you to try it. Draw a picture, label it, do something. It probably deals with something we've already done that day, correct? Probably. Okay, so we have this, and if I were going to draw this picture on my paper because I'm getting it out of the book, I would not draw the chair, the rug, the door, the table. I would draw just the angles. Make sense? Okay, the lighting designer is finalizing the lighting plan for an upcoming production. The spotlight can rotate 25 degrees to the left or right from the center. The beam of the light from the spotlight forms a 22-degree angle. Can the designer use the spotlight to light every object on the stage? So we need to do some math and figure things out. We need to figure out what this angle is right here. That one right there. I put it as X because we don't know, do we? No. We need to figure out both sides, don't we? We know that this whole angle is 74 degrees, don't we? Because they put it in blue. We know this whole angle here is 57 degrees. So we need to figure out X. And we also need to figure out this gap right in here. Don't we?
Yes.
We need to figure out those pieces. So what makes up 74? In the least amount of pieces. So 74 equals what? So 74 is the whole thing, right?
Yeah.
And from here to here is what? From here to here is what? 57. Plus what?
22.
X. 22 is the yellow. Plus X. That would help. We can figure out X there, right?
Yeah.
Okay. Now what about 57? What's it equal? What plus what?
22 plus X.
22, not X. Why? Because 57's right here.
23.
So 22 plus Y. So can I figure out what X and Y is now? And it has to be less than what? 25. Because if it's bigger than 25, am I going to be able to hit the object? No. Okay, so if I subtract 57,
23.
I don't think so.
It is. It's negative.
Oh, yeah, you're right.
I get 17. You guys get 17?
Yes.
Okay, so can we reach the table? So we can reach the table, right? We have a smiley face on the table. So, minus 22. So I get 5, 3. Can I reach the chair?
No.
No. I'm sad. Chair is going to be dark. If I can't reach the chair, we cannot do no scenes with the chair, correct? But what happens if I could, like, make my spotlight wider? How would I make a spotlight wider? How could I adjust it?
Make it brighter.
No, that doesn't increase the beam. If I moved it back, if I take a flashlight and I go up to the wall, it's write a circle on the wall, right? And every time I go back, what does it do to the wall? It gets bigger, right? So what if I adjusted the spotlight back and changed this right here, this angle from 22 degrees to 33 degrees? Well, I already know that this one's going to be a yes, correct? Because I got it at 22. It's this one over here that's causing me grief, isn't it? So I got to reset my, so it's going to be 57 equals 33 plus Y, correct? So I'd minus 33 for 24. Does it work now?
Yes.
Yes, so now I can get my chair. So like Shaylee said, I just need to move my spotlight back. Do you think I need to move it back a lot?
No.
No, because again, if you think about that flashlight on the wall, I can move it just a little, increase it, and increase what I'm shining it on a lot, can't I? So just a little. Now, I just kind of wrote some equations and did what I could, right? I didn't have this huge grand plan, but did I have a plan? Yeah, but it wasn't anything elaborate. That wasn't hard math, was it? No. Okay, this is just the 33 slide. Okay, this slide, every single thing is on your paper already. If you need to make things darker, then make them darker. Got it? There's some lines there and you need to be aware of them. When things are congruent, we need to talk about it. You guys will tell me that angle is equal that angle. An actual angle cannot be equal to another angle. Okay? An angle can be congruent, which means the size and the shape and everything are equal. But angle measures are actual numbers. Numbers can be equal, objects are congruent. Does that make sense what I'm saying, guys? Objects are congruent, numbers are equal. Do they mean the same thing? Yes, but that's the difference between the two words. If I'm talking about this triangle and this triangle, just the triangles, I said they're congruent. If I'm talking about angle 57, the 57 degree angle and the 57 degree angle, I say they're equal. Now, will we all mess those things up? Yep. And I'll keep trying to remind you, and you keep trying to remind me, and we'll probably get better by the end of the year, correct? Okay, so when two segments are congruent, that means they have the same length. We mark them. You see these hash marks? See that? So these two segments are equal, and the bottom ones, those two segments are congruent. And if we had a third set that are congruent, guess how many lines that would go on it? 3. And then what? 4 and 5 and 6 and everything. The symbol for congruent is right here. It is an equal sign. Oh, it has to give me a second. Won't let me write on there. It is an equal sign with an approximately half of an approximately symbol on top of it. Come on, you can do it. I believe in you. I believe you can fly.
Oh, with the little.
Yeah, it's right here. I'm trying to circle it. Try this again. It's right here. Do you see it? Everybody? Highlight it, note it. That's what congruent means. So people watching the video are trying to figure out what I'm pointing at, and it won't let me point. It won't let me do anything. I think I messed it up. Maybe not. I'm trying not. Please stop. Yes, Ryan. Okay, so we're going to talk about congruent segments and angles. And we know congruency by matching tick marks or arcs and angles. So these two, A, B, and C, D, are congruent. That symbol right there is congruent. It is right here. Highlight it there. Oops, I just colored over it. Probably not what I wanted to do. So a congruent symbol is just an equal, and it's half of an approximately above it. Much better right here. There's it right there. Okay, so these two are congruent because they have one tick mark. Right here. These two are congruent because they have two tick marks. And if I had a third one, I'd have 3, and so on. These angles, TUV and XYZ, are congruent because they have one arc. So they are congruent. And FGH and JKL are congruent because they have two arcs. If I had a third, I'd have a third as well. The difference between congruent and equal is measurements, so actual values are Angle measurements are equal and objects, the angle, the segment, and so on are congruent. So the next thing I have here is I have that we have some properties that you should already know, and I'm just going to throw them out there so we remember. The reflexive property right here just says that AB is congruent to AB and A is congruent to A and so on. Symmetric means that AB is congruent to CD, then CD is congruent to AB, A is congruent to B, B is congruent to A. And then we have the transitive property that says if AB is congruent to CD and CD is congruent to EF, then AB is congruent to EF being here. I don't know why my screen is not. Okay, so a couple of examples using our congruent segments. Up on the top it says if the measure of XWZ equals 127 degrees, what is the measure of YWV? So YWV is right in here. But I know that XWY and VWZ are congruent, so they are both 32 degrees. And the whole thing is 127, so 32 plus 32 is 64. So 127 minus 64 is 63 degrees. And so the measure of angle YWV is 63 degrees. Now you could have taken 127 and subtracted 32 and subtracted, I didn't subtract right. How about a 95? And subtracted 32 again. And got 63 as well. But just adding them together was easier first. Okay, so the next thing I have the measure of NOP. Well, it's the whole thing, NOP. The whole thing, NOP is 31, not the whole thing, degrees. And ROQ, so ROQ is what we're supposed to find. And now NOQ, the whole thing, is 114. So these two are the same. So I know that 114 is equal to 31 plus, and I'm going to name this X and X. Well, how many X's do I have? 2X. So I have 114 is equal to 31 plus 2X. So I subtract 31 on both sides. Equals 2X and divide by 2. So X equals 2 goes into 8 4 times. 2 goes into 3 once with 1 left over. So I'm going to put a decimal and a 10, and that's 5. So 41 degrees is equal to the measure of angle ROQ. Okay, and our last example is just going to give us a weird little shape. It's going to give me a weird little shape here. And it says, apply segment addition postulate and substitute congruent segments to find the lengths. Okay, we need to find HF. So HF is this whole segment down here from here to here. But I know pieces of it. I know that HG is the same as AH because of the double line, so it's 11. And then we know that GF is the same as EF, which is also the same as 8. So, one moment. So it's also... Okay, so we got interrupted. So let's see what we've got here. Then we need to have HG was 11. I just have to start over with my writing, sorry. And we said that GH was the same as EF, which is the same as BC, because they all have one hashtag or hash mark. So I'm going to put 8 here. I'm going to put 8 here. So if I want HF, that is HG, segment HG, plus segment GF, which would be 11 plus 8, which would be 9. And we need to use centimeters because they have centimeters. So now we have, suppose that CD is 11.5. So CD is 11.5 right here. And DE is 5.3. So DE is 5.3 right here. And the perimeter, so perimeter is we add up all the outsides of the figure, is 73.8 centimeters. What is GE? Well, GE is right here. But GE is the same as AB, and that's the only missing part of my perimeter. So if I add up all my sides, so perimeter equals the sum of the sides. So then it gives me 73.8 equals, well, I got 1, 2, 3 11s in the 0.5, so that gives me 33.5. And I have 1, 2, 3 8s, so that's 24. And then I have a 5.3. So I get 8, and then 7, 12, 62.8. So I have 62.8 plus AB. Well, then I would subtract 62.8. So 0.11. So 11 centimeters equals segment AB. But AB is congruent to GE, so it also equals GE. And that's your notes for today.